Welcome to Coffee, Contractors, and Concrete, a podcast brought to you by the team at Buy Manufacturers Direct, servicing the concrete and surface preparation industries with information, tutorials, equipment, and service. Today we continue our discussion with leading industry subject matter expert for concrete dust collection, Nick Gawlik of Ruwac, USA.
You mentioned exposure. So let's take it to the next step of the actual dust collection in the vac. You know, we've heard Longo Pack, the bag system, and then there's the bin system or bucket system. Can you touch a little bit on how they work? And again, you know, I know Ruwac works more on a bin system now with the bag, but the importance of collecting that dust, because a lot of the exposure to the operator can happen actually when they're emptying the bag and that sort of thing. So can you kind of touch on that, what the benefits or what the possible exposure is and when you're changing a bag?
Yeah, we see it's mainly based on preference. Regardless of a Longo Pack or a direct bagging system as opposed to a dustpan system, the operator should be wearing a respirator whenever they're emptying either one of those types of vacuums. So you should have respiration. If you're looking at a dustpan vacuum like ours, we do have a suggested operation of how you're going to do it. Number one, wear your respirator. If you're going to empty the dustpan, turn on one of the motors. We have a few different tricks or instructions that we like to give to people to minimize any of that exposure. And we'll do the same thing for direct bagging vacuums, but it's all preference. Ruwac has been known for many, many years for the smaller, compact dustpan options. But over the last several years, we've come out with direct bagging, and we offer it with clamping mechanisms. So you can use a general purpose trash bag, or we have a tray so you can use Longo Pack style bags. We present it to everybody. However you want it, your options are here. What is your preference? And everybody still today has their own preference. We still move a lot of dustpan machines. And as long as people are following our instructions in the way of how to empty it safely, exposure typically is not going to be a problem.
Okay, let's touch a little bit on length of hose and diameter of hose. I've been on job sites where guys are using 50 feet of hose, and other job sites where they're using 10 feet of hose, and they've got 2-inch pipe or 2-inch diameter up to 5-inch diameter. Touch a little bit about on what is the ideal configuration of hose and length in reference to the machine that you're using. And what I mean is, you know, what's ideal for a shot blaster versus a grinder versus a scarifier, and is there a preference or is there a right combination to that?
When it comes to overall hose length and diameter, the vacuum is going to dictate diameter. At Ruwac, we tend to factor everything at 25-foot length of hose. We know there's a lot of other manufacturers out there who might offer their vacuums with 50 feet. Even I've seen some people offering up to 65 feet as a standard hose length. The longer the hose, the more friction loss you have, which means you're just going to recognize a loss of performance. So there is a fine line. Now, if we're grinding with a PCD or a 30-40 grit tool, that's going to require one thing compared to if you're polishing a floor with a 400 or an 800 grit resin pad. So you might not be able to get away with those really long hoses early on, but later down the line, when you're creating a very small amount of debris, you can get away with a lot more. But generally speaking, the longer the hose, the more friction loss, which is going to equal less performance. When it comes to diameter, the diameter of our hose in this application is going to be dictated by what the manufacturer has to offer. So with a PrepMaster Junior, for instance, that uses a 2-inch port, or a PrepMaster 3030 uses a 3-inch port. We're going to size our vacuums and our hoses appropriately. But one of the big things that we always like to stress, especially with the larger platform equipment, you want to run the largest diameter hose possible to move the most amount of air possible for the best performance.
Are there tricks I've heard with shot blasting? You know, obviously there's the combination of where you want to suck the concrete dust, but you don't want to prematurely suck the shot. Can you affect that by the size or diameter of the hose? If you go to a larger diameter hose, does it reduce the suction? So you can maybe play around that combination a little bit?
It seems like with shot blasting in particular, they've already got it figured out, and Josh can maybe chime in a little bit, knowing more about the impacts side of shot blasting versus my experience with Blast Track. But it seems like they already had it figured out, where that 50-foot section of 5 or 6 inch hose is already kind of factored into their mathematics. I can't speak for now, but on some of the older dust collection systems from Blast Track, you would see that they had like a gate valve in there where you could open or close that valve a little bit if you noticed that there was too much suction. But it seems like, generally speaking, when you buy a dust collection system to go with a shot blaster, all of those things are already factored in and taken into consideration.
Josh, with your experience with impacts, how would you answer that question? Are there tricks to it? Does the diameter of the hose play a primary role or function in that, or is that just kind of old industry hearsay?
Well, on the bigger ones, I think I would be more concerned about having the right diameter hose, and that's determined by the machine's outlet. So on the bigger ones, you got the 12.5 inch has got a 5 inch, the 16 and 22 inch has a 6 inch hose. So that, according to impacts, is going to need to be the hose that's used all the way back to the dust collector. The amount of air that needs to be moved, the lift, that's already determined by the design of the machine, because X amount of volume of waste that's being made that has to be moved from the machine or the point of creation over, let's say, 50 feet, which is a standard hose length, to the vacuum. That's what the engineers have come up with as far as how much air needs to be moving through that circuit to pick the shot up, to bring the dust with it, and then also effectively separate the two before the shot is returned back into the circuit and the dust is moved to the vacuum. With regard to the small one, we messed around with the little 210 with different size hose and different lengths of hose. We actually found that and again, this is just kind of one of those tricks, like Nick was saying, that we figured out. We actually had to restrict the outlet on the small blaster to limit the amount of shot that was getting to the vacuum, where the hose length didn't really affect it that much because we had more suction than we needed. So we actually had to slow down the air that was moving through that machine. But when it comes to the blasters, unlike a grinder where it's like, the more suction, the better, with a blaster, there's such a thing as having too much for the reason you gave. You can definitely lose shot. And if you don't have enough, it's not that you're going to leave dust on the floor, you're going to have dust inside that machine, and that's going to cause premature wear on your shot blast wheel, your blaster wheel, your liners. A whole bunch of different stuff is going to affect the overall performance of that machine. And that's true of any shot blaster. So, I mean, when it comes to the blasters, I definitely, personally, if I don't already know the answer, I'll defer to the manufacturer of the machine.
Okay, let's move on to power. And by power, I'm talking 110, 220, all the way up to 48, or even gas. There are a lot of different power options on a lot of different vacs out there. Nick, touch a little bit about, I know if you've got less power, you're probably going to get less suction or less CFM. But I'm sure there's some sort of correlation between more power, more CFM. But some contractors are restricted by either power on the job site or by generator. So if you could touch a little bit about on the power itself, and are there any limitations to a smaller machine with less power coming in than, say, a larger machine?
Yeah, generally speaking, it's going to be the same as if we're talking about grinding equipment. You have your limitations to what you're able to do with a 110 volt machine. And when you require more power, that's when you start getting into larger 220 volt, 460 volt, single phase, 3-phase units. With 110 volt, you can only provide so much power to the vacuum producer, to the engine, to the blower, whatever it might be, that's going to eliminate the performance. So 110 volt is going to give you a pretty good range with smaller platform equipment. And then you have all of your additional options as your platform sizes start to grow. If you're running 30-inch platforms, but that power is not available, if it's not available to the grinder, that means you're probably running a propane grinder, which means you're going to start looking at a propane vacuum system. So you have plenty of alternative power available: gasoline, propane, air-powered vacuums. But generally speaking, the more power you need, the more power you need to provide.
Okay. Let's move on to basic general maintenance of these machines. And we've touched a little bit about earlier about the filter and some other things, but what are some of the things a contractor, either before every job site or once a week, once a quarter, however many hours they're using it, what are some of the things, Nick, you would recommend that a contractor look at in order to A, get the best performance out of his vac, and B, extend the life as long as possible?
Well, kind of going back to where we started, the most important thing is for reduced exposure of dust to the operators and fellow tradespeople. So that's going to be the number one most important thing we need to look at. Beyond that, what's the importance of it? We want to extend diamond tooling life. So the better your vacuum system, the cleaner you can keep that floor, it's going to help extend your diamond tooling life. It's going to minimize the amount of work that needs to be done in between each step. The cleaner that floor is throughout that process, there's that much less work you need to do after the fact. So you're going to keep the job flowing a little bit quicker. You're going to be more productive and cut down on labor. It's going to help extend the life of your other equipment by moving that dust out, like Josh touched on previous, when it comes to a large amount of dust bouncing around inside a shop blaster, that can shorten the life of certain components inside of there. So making sure you have a good powered vacuum for your application is going to help with exposure to operators, reduce diamond tooling cost, increase production, more profitable.
Well, that kind of answered my next question. The next question is going to be, how do you respond to the contractor that says, I'm just going to go to Home Depot and buy a shop vac, it'll do the same thing? And I think those value propositions that you just laid out are that's the answer to that question, that you get what you pay for, and it being able to have the right vac on a job site will pay for itself, and it's also a safety and a liability issue. Nick, is there anything that we missed? Or is there something our viewers would like to know, that some topic or something about a vac that would help them make a smart purchase, or give them information to go out and to make a wise purchase?
I think just kind of running through everything we talked about, it's making sure you're getting a vacuum that's going to be designed specifically for your application or applications, making sure it's sized properly, making sure you're buying a vacuum that's going to be the most durable, with the best filtration that you can find that will work for your budget. But aside from all those things that we reviewed, one of the things we haven't talked about yet is basic equipment maintenance or vacuum maintenance. At the end of the day, the cost of ownership is a phrase that we like to talk about a lot. We constantly try and remind people of. You might pay a little bit more up front. You might pay a little bit more with one of our systems than you would with a shop vac. But you want to look at that cost of ownership, and the lower that is over the long run, the better off you're going to be. And your basic maintenance is going to be a large part of that. So filtration, checking power cords, and again, that becomes a safety thing, which we touched on briefly. Making sure we're minimizing the chances of somebody getting shocked or electrocuted. Checking the seals and the gaskets, and looking out for missing hardware that can create vacuum leaks. Checking the your air filters and oil levels with alternative powered machines. We just want to make sure that people are always keeping that maintenance stuff in the back of their mind too.
Great. I appreciate it. Josh, anything you'd like to add?
Yeah, I have a question. Nick, you had talked about, or we were discussing the CFM and the water lift. I was just thinking of an advertisement I saw the other day for a vacuum that the CFM and the water lift, as it was given, based on my experience and the size of the machine, speaking with another contractor, we found it difficult to believe. Now, I know in our industries, there's no regulation really whatsoever for the numbers that are presented by different manufacturers. When it comes to a contractor trying to pick a vacuum, and let's say that, I mean, they really don't know the size of the vacuum they're going to need, and they don't necessarily, when they look at that vacuum, question anything but the numbers. Again, relying upon whoever it is that's providing that information. Is there any kind of calculation in terms of CFM, water lift, how that's calculated, and also the amount of mass that's inside that circuit at any given time of the process? Meaning, if I'm filling, let's say, a Longo pack bag, and I'm putting 30 to 40 pounds inside that bag inside 30 minutes, and I have whatever the fixed number is that's reported of CFM and water lift. Do you really get into that minutia when it comes to how stressed that system is or that circuit is based on that amount of mass moving at a given velocity with the water lift? And I'm speaking like a physicist here, which I'm not, but I'm speaking from the standpoint of the contractor that's trying to make an informed decision. And I don't know that those numbers help to clarify what they should buy.
Yeah, those are all great questions. I am far from a physicist. We have people at Ruwac in the office who focus on that kind of stuff. That's way beyond what I can figure when it comes to those mathematics. We try and keep it simple, and there's some basic math that works. Everybody automatically wants to look at the highest CFM number, the highest lift number that they can get, and that's going to be the greatest thing. In theory, yes, okay. But there is a manufacturer out there who's going to claim a 300 CFM vacuum, but they're going to try and do that through 1.5 inches of hose. You can't do that. So yes, that specification might be there, but it doesn't necessarily apply to that real world application. So you really have to look at a lot of other things. Hose diameter size, hose length. You brought up the point of the material and how much material. All different materials and different masses can also dictate how this stuff is going to work. Are we working with a really fine concrete dust? Are we trying to pick up gravel or large debris after a demolition job? Yeah, there's a lot of things to take into account. And that's where we come into play as a vacuum manufacturer to help give you that guidance. But just looking at the highest, largest, biggest numbers of CFM and lift don't really solve the problem for you, because a lot of times you're never going to use either one of those numbers at that maximum number anyways. So yeah, a lot of those numbers don't mean much, to be honest with you.
Another question, how much, and just speak about your brand, over the life of the filter, if it's got a 3-year warranty on that filter when it's used correctly, is there any kind of calculation or time that, let's say, the airflow or the lift will change or vary based on the age of the filter?
Another great question. Yeah, you can see with the aging of the filter how that material might start to stress a little bit. Now, the way our systems are designed with our filter inserts and our cage, even as that filter starts to see several years of use, it's prevented from collapsing on itself, which is something that would cause some performance issues. So each filter design is going to be different, impacted differently throughout that process of based off of age, type of material that they're recovering, pulsing systems or non-pulsing systems. Those are all things that can be taken into account.
Cool. Great. Well, unless there's anything else, guys, Nick, we really appreciate your time. I think it's been very educational. And we look forward to having you maybe on a future episode to continue our discussion.
Sounds great. Thank you for the opportunity, guys.
Thank you, guys.
Thank you.
This concludes episode 12 and our final season 1 episode of the Coffee, Contractors, and Concrete podcast. If you've enjoyed listening to our podcast, we would appreciate your feedback. Please feel free to reach out via email or the comment sections on our various social media platforms. Again, for immediate access to hundreds of industry tutorials and product demonstration videos, we invite you to visit the By Manufacturers Direct YouTube channel. Simply visit the By Manufacturers Direct homepage and click Watch More Videos. New videos are added weekly, so don't forget to subscribe, and please click that bell icon to be notified when we post a new video.